In this video, we will try to prove the Walras law. Okay, this video is in continuation to the earlier videos on general equilibrium analysis. Okay, the statement of the Walras law is that value of excess demand is identically equal to 0 for all prices. We need to prove this very statement. Okay, so we have assumed in the earlier videos, we have two good model. Each person has some initial endowment. Okay, so we will use that very kind of information in getting the proof of this Walras law. Okay, so to get more idea how will I derive this, you should watch the earlier videos also. Okay, so let us say we have two persons, person A, okay, and person B. Okay, we have two persons and two goods. Now person A is demanding, let us say XA is the allocation or demand of person A. He is demanding XA1, that means units of good 1 person A is demanding, and XA2 means units of good 2 person A is demanding. Also this person A has some initial endowment. WA denotes the initial endowment of this person A. Let us denote it by like this, WA1, that means initial endowment of good 1 by person A, and WA2, that is the initial endowment of good 2 person A has. Similarly for person B we have XB, that means the allocation of the two goods by person A is equal to XB1, units of good 1 person B is demanding, units of good 2 person B is demanding. And similarly this person B will also have some initial allocations. Let us denote it by this, W1B, units of good 1 person B has initially, and W1B, sorry, 2B, units of good 2 person B has initially. Okay, we have 2%, two good pure exchange economy. Now we take this person A. Let us see what is his budget constraint or what is his total expenditure and income. Okay, so his total expenditure should be equal to his total income. What will be the total expenditure of good person A, sorry. So he has X1, XA1, okay. Also he has XA2. So these are the demands of good 1 and good 2 by person A. It will be equal to the price of good 1 plus price of good 2. Okay, so this is the total expenditure. Simple stuff. Units of X1 he is demanding times the price of good 1 plus units of good 2 he is demanding times the price of good 2 should be equal to his total income. And we have also assumed there is no outside income. Okay, so income of the person is the endowment he initially has. Okay, so what the person has initially, he has this endowment. And what will be the total income then? Simple, price of good 1 times the initial units of good 1 the person has plus price of good 2 times units of good 2 initially he has. Okay, so this is the value of his endowment. You can call it the income of the consumer. Okay, he has no outside income. We have assumed in the earlier general equilibrium analysis videos. Okay, so this is the total expenditure, rather this is the budget constraint of the person A. Okay, now I can rewrite it also. So if I write it like this, P1 XA1, I will transpose this term, that is minus P1 WA1 plus, then I write this term P2 XA2 minus this term P2 WA2. When I transpose these terms, it should be equal to 0 on RHS. Let us take P1 common. So we are left with XA1 minus WA1. Okay, take P2 common here, and we are left with XA2 minus WA2, it should be equal to 0. Now what is this XA1 minus WA1? So see it carefully. XA1 denotes the gross demand of good 1 by person A, and WA1 is the initial endowment of good 1 by person A. Okay, so the difference between these two should give us the net demand or the excess demand. Okay, simple step, I will explain it here. Let us say person A is demanding, let us say, 5 units of apples. Okay, also person A has initially 2 units of apples as endowment. Okay, let us say this is W, this is X. Then net demand will be equal to what he is demanding, that is gross demand 5 apples. Okay, from this he will obviously subtract what he has initially he has 2 apples. Okay, so the difference between these two will give us the excess demand. Okay, simple thing, a person A is demanding 5 apples, he has initially 2 apples with himself. Okay, now net demand will be equal to his total demand of the apples minus the demand, minus the endowment of apples he initially have. So this denotes our excess demand. Similarly for good 2, we have gross demand for good 2 minus initial endowment of good 2. So these are the net demands or excess demands. So can I write it like this? P1, in this place I will write E, okay, EA1, that means an excess demand of good 1 by person A, plus we have P2, and here I can write EA2, that means excess demand of good 2 by person A, it should be equal to 0. Okay, so these denote our excess demands for good 1, this denotes the excess demand for good 2. Okay, what about person B? Simple thing, let me write it here. For person B also, let me write it here. What is his total expenditure and income? Total expenditure will be equal to price of good 1, okay, times units of good 1, that means XB1, plus price of good 2 times units of good 2 for person B, should be equal to his income. What will be the income of the person B? His initial endowment and its prices when we multiply. So this is P1 times the initial endowment of good 1 person B is having, plus P2, the initial endowment of good 2 person B is having. This is the budget constraint. This shows the value of his endowment, and this shows the expenditure of the consumer on good 1 and good 2. Okay, writing it in this fashion as I have derived it here. So we have P1 XB1, transposing this term first, minus we have P1 WB1 plus P2 XB2. Now transposing this term, it will become minus. So we have P2 WB2 should be equal to 0. Now taking taking P1 common, so P1 we take common, we are left with XB1 minus WB1. Here we take P2 common, we are left with XB2 minus WB2. It should be equal to 0. Okay, now what does this show? This shows excess demand of good 1 by person B, as I have explained it here. This shows the excess demand of good 2 by person B. So I can write it like this: P1 into, in this place I will write EB1, excess demand of good 1 by person B, plus P2 into B1, that is excess demand of good 1 by person B, should be equal to 0. Let us say this is equation first, equation second. Okay, now add up these two equations. I can add them easily. So we have P1 E1B. So let me add it here. So equation 1 plus 2 gives us, so we have P1 EA1 plus this P1 EB1 plus, then we have this P2 EA2 plus this P2 EB2 should be equal to 0. Okay, so I can do one thing here also. Let me take this P1 common. So if I take P1 common, I am left with EA1 plus EB1 plus P2 EA2 plus EB2 should be equal to 0. Okay. Now what does this EA1 plus EB1 show us? EA1 shows the excess demand of good 1 by person A. EB1 shows excess demand of good 1 by person B. Then this all shows us the aggregate excess demand of good 1 by person A and B. Okay, so when we add these two, so it will show us the aggregate excess demand of good 1. This will show us aggregate excess demand of good 2. Okay, so can I write it like this? P1, in place of this I will write, let me write it like this, P1 Z1. That means aggregate excess demand of good 1 by person A and B. I have denoted it by Z. Okay, plus let me write it here, plus P2, and this also shows aggregate excess demand of good 2 by person A and B. Let me denote it by this Z2. Okay, so Z2 shows us the aggregate excess demand of good 2 by person A and B. Okay, and it is equal to 0. Then okay, so this was, first we have this stuff, then we have this stuff. Now let me write it here. Now I can write it like this, P1, okay, Z1, and Z1 aggregate excess demand of good 1 by person A and B will obviously the function of, so I am writing it in terms of function, that is P1 P2. Okay, you can write it here also, so but for the sake of simplicity I am writing it here like this, P2 into Z2, which is function of P1 and P2 is equal to 0. This is our, Walras law. It says aggregate excess demand, okay, is identically equal to 0 for all prices, not necessary at the equilibrium prices, but on all prices. Okay, how do we interpret this? Okay, let us assume if this Z1 is equal to 0, let us say if Z1 is equal to 0. If Z1 is equal to 0, what does this mean? This simply tells us aggregate excess demand of good 1 is 0. Okay, so it shows us aggregate excess demand of good 1 is equal to 0. Okay, that means demand of, good 1 minus supply of good 1 is equal to 0, and this is the definition of the excess aggregate excess demand being equal to 0. When demand of good 1 minus supply of good 1 is equal to 0, we say aggregate excess demand is equal to 0, which gives us simply demand for good one is equal to, transposing it here, supply of good one. Okay, that means good one, market for good one is at equilibrium. The equilibrium condition is that demand is equal to supply. Okay, that means our good one is being cleared, so it gets cleared, it is in equilibrium. So when z1 is equal to 0, good one is in equilibrium because demand for good one is exactly equal to supply of good one. Okay, now what about this? We have assumed z1 is equal to 0, and let's assume here price, that is price of good 2 is greater than 0. Okay, so it cannot be negative, so we don't have negative price at all, and it may happen to be 0, but for the sake of proving this, I am taking it greater than 0. Okay, now if z1 is equal to 0, so let me rub this here. We have seen if z1 is equal to 0, this whole term becomes 0. So this is 0 plus we have p2. Okay, p2 times what should be equal to 0. So if z1 is equal to 0, okay, so this term is equal to 0, then to hold this idea, this equality, if first term is 0, then the second term should obviously equal to 0, and we have assumed this p2 is greater than 0, then this implies this z2 should be equal to 0. If this is not equal to 0, prices are positive, then this whole term will not become 0. This whole expression will not become 0, because we need to hold this identity. So remember carefully, listen carefully. So the addition of these two terms is equal to 0. First term is 0, then second term must be 0, because if p2 is greater than 0, and if this is also greater than 0, so this identity will not hold, it will become, there will be an inequality. So if p2 is greater than 0, then what we need to multiply p2 by, so that this whole term becomes 0. Simple thing, that means this z2 should also be equal to 0. Z2 should be also equal to 0. By z2 being equal to 0, what we mean? We mean excess demand of good 2 is equal to 0. That means demand of good 2 minus supply of good 2 should be equal to 0. Okay, that means transposing demand of good 2 should be equal to supply of good 2. Okay, so demand of good 2 is equal to supply of good 2. That means market for good 2 is also clearing, so market for good 2 is also in equilibrium. Okay, so we have seen the value of excess demand is identically equal to 0 for all prices. Okay, now what is the implication of the Walras law also? So let us show the implication of the Walras law also. So I have to rub some stuff here to make the space. I don't have, infinite number of space, so what should I, so let me rub this out. The implication of Walras law is simple. It says if n minus 1 markets are in equilibrium, then nth market will also be in equilibrium. Okay, simple thing. It says if there are n markets in an economy, if n minus 1 markets are in equilibrium, then nth market will also be in equilibrium. Let us say we have 10 markets. Okay, if 10 minus 1, which is equal to, if 9 markets are in equilibrium, that means the 10th market will also be in equilibrium. In this case, you can see we have actually proved this here. We were having only 2 markets. Okay, so n minus 1 means 2 minus 1. If 2 minus 1 markets are in equilibrium, okay, that means first market is in equilibrium, then nth, that means second market, is also in equilibrium. Okay, so since we have only two markets here, we have seen if market for good 1 was in equilibrium, market for good 2 was automatically in an equilibrium. Okay, so we were having only two markets here. So if 2 minus 1 markets were in equilibrium, so let me put it here to explain it here. So we have here 2 minus 1, that means markets are in equilibrium. Okay, so 2 minus 1 is 1. So if first market is in equilibrium, that means then second market, that means second market is also in equilibrium. Okay, so this is the implication of the Walras law. If we have n markets, in this example we have taken only two markets, market 1 for good 1 and market 2 for good 2. Okay, so first market was in equilibrium, then second will also be in equilibrium because we have only two markets here. I hope I make myself clear in this video. Thank you.